Well, hey everyone, Jason here at Alorium Technology, and this Friday afternoon I was going to go through a little test and checkout of something we updated this week just to make sure it works for me as well. And I thought, this would be a fun thing to do and maybe throw on YouTube if it all works out well as a little tutorial in case people might want to give it a try as well, and also to kind of prove out or show maybe how easy this actually is. What we've got going on is we have a customer that bought some of our hardware, wanted to use our quadrature accelerator block. But the thing is, when we originally designed this, when we first released it, we were really looking at like really high precision quadratures with lots of clicks per revolution. And anyway, some of the design assumptions we made when we first pushed it out there didn't apply really well to simple things like a little just hand rotary encoder or something you just turn very slowly. The features to accommodate that were there; they just weren't brought out and made easily available. And so we needed to fix that. So we did that this week. And eventually we're going to release the new images out through our standard delivery system or the standard release flow through Arduino. But what I wanted to do instead, or what we need to do, is get this customer an image. And so one of the things we have is we've actually got on our GitHub page, so if you go to GitHub/Alorium Technology, we have a repo called Alorium FPGA images. And what we do here is we keep images that we release, both in terms of formally released images, the ones you would get in our Arduino releases, but and also some beta images. So we periodically will create images that we're testing with or doing things or doing demos and people want access to them, so we'll put them here. Or maybe once in a while we'll get a customer request that makes some sense for us to say, yeah, we can create one for that, make sure they keep going, and we'll put them out here too. Also, something that I added this week were some instructions about loading new FPGA images. We have a handful of videos on YouTube for how to do this, whether it's through the Arduino IDE, on the command line, or also with this RPD image web loader page that we have. It allows you to do it through the web. We've got those instructions now on GitHub also, so that's something that is new. Now, what we're going to do today is we're going to use this command line option to upload it, because for those of you familiar with our hardware, you can upload the FPGA image through the Arduino IDE or right through the USB, which is great because you don't have to have a JTAG connector to do that. Now, if you have an image that's not released through the Arduino IDE, in fact, I'll just do this real quick. I've got Arduino running. The way that works, I'm not going to actually do it here, is you select the image, the board that you have. In this case, I have an accelerate plugged into it, and then you just select the image you want, and then go down here to burn bootloader, and it'll actually update the image right through the USB. That's very powerful. But sometimes it might not be one of the images that we've released, so it's not in this list. And in that case, you need to do it a different way. And that's what we're going to look at by using the command line. So the image we're going to use is for accelerate. So we'll click on accelerate here, and you'll see that we have a whole bunch of images. And we've got all of our released images, which are the ones you would see in the Arduino IDE. And then down below here, you've got the ones that we are just kind of beta. So the one we just added was this four-quadrature, as I jokingly call it the quad. And that's the one I want. I'm going to have to grab the raw data here. So we'll download that RPD. And now I've got that RPD in my downloads directory. And what I'm going to do is go back here, because I do have the command line. I don't have it committed to memory. And it's a little tricky because you have to actually point it, this accelerate reconfig, which is the program you need to use, lives deep in the Arduino package, the boards package. And depending whether you're on Mac, Windows, or Linux, it can be in slightly different places. And I'm on a Mac right now, so it's going to be in my username and then /library and then all down this path. So when we bring up the terminal window, we will just try to remember where that is. Now I'm going to use this. We've got I think a list ports thing that I want to use so that I can see what port this is hanging off from. Now, another way you can do that is you could go and look here, and we could see that it's plugged in. We'll look at the port, and actually, I don't have it plugged in right now. I've got it plugged into the wrong port. Hold on a second. I had it plugged into the charging USB port on my hub instead of one of the connected ones. Okay, so we have this is our USB serial connection, and what I'll do is I'll just go ahead and run that command anyway. So let me bring up my terminal window. And I'm actually sitting here. If you look at the path I'm in, okay, so I uploaded this. So I'm actually sitting here in my GitHub directory that has these images in them as well. So I might as well just use the one that's sitting right here instead of pointing back to downloads. So what I'll do is I am going to first I need to go back and say, okay, where is that path? So we'll come back to this and we'll see if we can easily get there. So we'll say users, oh, look at that. How about that? I already have it committed to memory. So we'll do list ports. Okay, so this is the port that we want. So when we do our command, that's what we're going to want to use. So again, we'll go back to our full accelerate reconfig, and I'm going to sneak back here. Okay, what do we want to do? I want to put it on this port. So I'm going to use port 3, or no, I got to give it the full port, don't I? Okay, again, I don't do this all the time, so I'm remembering too. And the RPD file I want to give it is the one that's just here. So accelerate C16. And heck, I'm just going to do it this way, faster. All right, this gets to be a long command line. And then the load image, I want to do a load image 1 right here. This is the one that's the application image. You don't really want to do this factory image unless you really know what you're doing. And I think that's the last that I need to do. So I'm going to do load image 1. Now what I'm going to do is I'm going to add real quick some imagery or some video of the board so you can kind of see what it's doing, although it's going to be probably a little boring. Okay, now you can see the accelerate board there, and you can see the rotary encoder that we got so we can test it. I'm going to click this and whoops, click over here, and we'll get started. And we should see the accelerate lights blinking a little bit once this thing starts loading. And this takes a couple of minutes. What I should have done is, and I didn't shoot, if you look here, there's actually a verbosity you can set. And I should have set that to the highest one so we could actually see what's going on. And it would dump out some data here. In this case, it's not going to. So we're just gonna have to kind of wait until the blinky lights are done. But what it's doing is it's going in, and we actually have a little utility that is on the micro and the FPGA and some logic that allows us to be able to swap out the FPGA image that's on that thing. Again, very handy and very powerful little tool. So we'll just wait till this is done. All right, it is done updating. And one of the things it does is after it updates the FPGA, it'll run this tool we have called Git Accelerate version, which goes out and queries what's on the FPGA. And what we can see here is this is hardware version 3000, which matches the SVN number for this. And it's got 16 megahertz, and it has the quadrature XB on it. So looks like it worked. Now what I want to do is I want to run a test sketch that we developed for this. So we have this sketch called Simple Quad by 4. And this is just a variant of, if you grab our boards package and you go under examples, you can grab a simple quadrature sketch. And this is just a variant of that accommodates the by 4. What we are doing here is because I only have one of these encoders right now, I think I'm just going to set up a single quadrature. Actually, I guess we can just do it down here. This will configure a quadrature, all 4 of them on these pins. And then down here, it's just going to read the one out. So I've got it. I'm going to have you can see I've got it plugged into 2 and 3 here. And hopefully this will work. So let's update this thing. We'll make sure we have this set correctly. Accelerate 16 megahertz. Now this isn't going to apply. So, you know, having it set to this 16 megahertz image of any kind will probably make sense because it does some things with the timing in terms of delays and stuff like that. So if you had one of our 32 megahertz images on there, you probably want to set it to 32. We've got the port set right, and let's see if we can upload this thing, and then we'll find out if it works. Because I've not actually used it yet. I was working with our customer earlier in the week, and then some of my colleagues made the changes the last couple of days, and of course we're not all working together right now, so I had dropped off the rotary encoder at our office so it could get tested, and this was done, and then I picked it up, so now I'm kind of looking forward to trying this out. Let's see. Looks like we've got that, so that must be working, 115.2. So now we should get a nice tight response. If I turn it to 50, we should go to 50. Looks like the directions, so this is set up counterclockwise, actually counts up, so it's backwards, but that doesn't really matter. We could easily change that in the code. The key thing is are the number of clicks appropriate? This has got 100 clicks per revolution. So what I'm going to do is I'm just going to spin this around and go all the way to 100. Boom. All right. I'm also going to set this so you don't have to see my family texting me. Okay. So that seems to be working out okay. If I go back this way, I'm going to go back to 0. I should be able to go the other direction. Hey, all right. Seems to be working just dandy. So that is with accelerate. I guess you guys can't really see that in this video when my hand's in the way. But I'm trying to look at it through the lens of my phone as well. So we're at 90. Looks like we're at minus 90. If we go back to 0, we should go back to 0. Boom. All right. Hey, that's working great. So that should work out really well for those guys. So very cool. So if that's something you're interested in, now that image that's out there, that's all it has on it, just those 4 quadratures. So if there was anything else like servo or floating point or anything else that you wanted to use, it's not there. But this is something that we will update these changes to this Quadrature XB, as well as you can see in this sketch, we have some explicit rights to registers to set the quadratures up in by 4 mode. This is something we will add to our library so you can do a call like this, right? So instead of having to do this kind of a register right, you can just simply say, hey, set it to this mode and it'll just work. But I want to get this out right away. So that is it for this video. Looks like it worked and the whole process seemed to work pretty well. And hopefully maybe you learned a little something, give you some ideas if you're using our hardware and you want to be able to, take in quadrature information. Easy way to get started testing it out anyway. Also, one thing I'll point out, I like to do this a lot. This thing obviously has connections on the bottom of it, and so it's not great for just setting on a desk. And one of my favorite things to turn into enclosures of certain kinds are candy containers. I've done this with a couple other ones, and these mint containers are pretty handy. And I happen to have this one in my car, which was empty. And so I cut some holes in it, and now it's a great way. I actually stuck some little sticky stuff, a little feet on the bottom of that now, so I can turn it and move it around. And one of the things that drives me bananas is anything metal that just kind of rubs around and scratches on the table. Anyway, that's a little bit of some insight into my weirdness about putting rubber feet on the bottom of everything, including like these boards and anything that has to sit on a table. But that's a little more information than you probably cared to get in this video. Anyway, thanks for watching. Hope you learned a little something today. If you want more information about our boards and our hardware, you can head on over to aloriumtechnology.com. And we've got a whole bunch of information about the boards and the products that we have. You can check it out here. If you want to just run over and start buying stuff, we can encourage you to do that by hitting the shop button also. Oh, that's right. I meant to talk about this also. We do have this web loader that we made available. This is still kind of in beta mode we were playing with last fall. And it's still, or maybe early in the year, I lose track these days. Anyway, there's a way you can do this. There's a whole bunch of information. We have a video about how to use it as well. So I won't get into that here, but I wanted to bring it up because the one thing I'll say is we don't have this page updated with those quad images yet. So we'll try to get that done here fairly soon. But this just all took place yesterday. So wanted to get them on GitHub. They're available. We'll eventually make them available here on the web loader also, in case that's something you're interested in. Alrighty, that is it for this video. Thanks again for watching and listening. If you have any questions, shoot us an email at support@aloriumtech.com. We'd love to help you out. All right, take care, and we'll talk to you soon.